Hi, and welcome to class 2 of Axiom Pyro GPU simulations. In this class, we're going to be taking a look at the Pyro burst source and all its controls to create a beautiful and detailed explosive impact. So let's jump into Houdini and we'll take a look at setting up the controls for this system. So there's many ways to source fire and explosions that you can use in Houdini. One of the ways that we used to do it in ILM was we would have spheres, which we would source at the position of the explosion, and then these spheres would have like a noisy emission inside them, and then particles would stream out of the spheres and push the explosion outwards in from the position of the particles. Now, one setup that's similar to this, if we go into the simple effects shelf here, is the simple ground explosion. So if we just load this on here, and we're just going to load that on here. This has got using a system called the Pyro Burst, which is very similar to the system which I previously used in the effects team at Lucasfilm. So rather than setting up particles, which are set up manually, where you have to do like a pop network and then the particles spawn and then they basically like trail out with noises and effects on it. This system is using replicating points to basically create a series of explosions using this pyro burst source. So let's just have a look at this pyro burst source in this simple example, because it's one of the easiest ways you can see how it works. So basically what it has is it's got a pre-made shape which is effectively blasting out like a cluster bomb of explosions. But it's not like a real simulation where the particles like fly out and then fall onto the ground, and these tendrils kind of like have follow through on it. But it's still a cool little shortcut kind of shape that you can use for creating explosions. Now, if you see a real explosion like the on YouTube or on Vimeo, what you'll see is that there's an initial spiky shape that's really random, and that initial velocity and shape and the randomness of it is super, super important for creating an interesting follow through on your explosion. There's a good general rule for explosions is that a boring source shape is going to make boring explosion. So you can't just rely on all the fancy settings in your pyro solver to get you over the line. You need your source shape for fire and explosions to be really interesting, have a lot of variation in it, and the more interesting the source shape and the more natural and random its emission is, the more detail you'll get in your pyro solver when the source shape hands over its data over to the pyro solver, and you get your explosions. So let's take a look at what we've got here. We've basically got these spiky pre-made setups. And what you can do is they basically connect into the pyro solver. So let's just go down to see that these are rasterized. You can see here that they're then turned into volumes. And then this is connecting into the pyro solver in here. So we're going to use this in Axiom in our example. But basically, what I'm just trying to show you is just the end result of how these basically are used on pyro solver simulations. So you can see here you get your outwards expansion, but basically where these sort of mushroomy parts on the simulation is the spikes of this pyro burst source. So the initial blast shape basically continues outwards and creates this super cool looking explosion shape that you get to see in the end result. So that's one of the ways that that Houdini has made shortcuts for FXTDs for creating pyro bursts and creating explosions. Now, from as good as the pyro burst is, if we just go down and take a look at it, so yeah, if we just look at the pyro bake volume, you can see here you get some really cool looking effects from those pyro bursts. So let's take a look at the pyro burst, and we'll just have a quick discussion about other methods that you might use. So you can see here we've got this pyro burst blasting out of the ground here, and there's different scales, and it basically scales up and gives you these spiky kind of shapes on it. Now the thing is that this is a good system, but probably an even better system would be to use the vellum grains solver and have an initial shape which is on the ground, which would be like a small piece of dirt or bricks or any kind of smashable grains object, and then have the soil and debris stick together. And then as you basically blow that up with a simulation rather than just the pyro burst source, you would actually have trails and emission coming off the debris pieces. So if you imagine the trailing edge of this little piece here would have a vellum grains piece of debris, which is then emitting the density and the temperature off the piece of debris from each section of it. And then as the gravity would go down, these would continue along and then fall on the ground. Now that would be a much more involving setup to do per shot and per element. But basically what's good about the pyro source is it doesn't have any true simulation in it. It's not like a pop network that simulates with gravity, and this is the ground plane that it simulates on. And the same with the trails. It's sort of like fake particles, which is incredibly fast to set up and make changes to. And the simulations that are connected to it will give you really cool results really fast, especially using Axiom. So let's jump into our example scene with Axiom, and we'll see how that can connect into our pyro emitter. So this is class 2 scene file, and inside here is our hero final explosion setup. So it's a good idea inside this effect blast network, if you don't use this file for experimenting and learning about how to change all the settings in these nodes. If you want to change all the settings of all of these different nodes in here, what's a really good idea is just do what I've done here and just duplicate this this setup so that you can keep this one beautifully intact, because there's a lot of very carefully set up parameters inside here that are tightly linked into creating the final look of your explosion. So whether you back this file up or just duplicate that node, just keep this one intact so that you're able to, at any point, simulate through this as we're working through the class files and get to the super detailed explosion simulation at the end. So this one here, effect blast test, I've just duplicated this one. And inside here, I've got a more high performance, semi-real-time pyro burst and pyro simulation that you can basically play back in almost real time. So I've just file cached the pyro burst simulation on here. So as it plays through, it'll basically get to where we've set up whatever pyro burst setup you want to do. So that's our little pyro burst here. And then it will, so I've got this spiky random explosion, which is different to the main one. And then inside here, we can now use this with our Axiom solver. And we've got the division size set super low to 0.2. And what that'll allow us to do is basically play this back almost in real time in the viewport. So let's take a look at just playing this back. So we just got Axiom Solver 5 selected in here, and we're just going to press play on our viewport here, and we should be able to see that we're able to play this back into a super cool looking animation. So this is where you can see our spiky shape that we're sourcing off our explosion. And then you can see this huge vertical plume of smoke here, which is very different to our previous simulation. So a lot of the settings will keep the same visual style of your original setup, because you haven't changed the buoyancy, the turbulence, the disturbance, and all of those sorts of things with your sim. Plus, we've got a quarter of the resolution, but you can see here this spiky shape, which we're starting from here from our source emitter, is giving us this really cool explosive vertical starting point on our shape. And then as our explosion expands up, you're getting a really interesting kind of verticality to your shape, as well as some really interesting tendrily noise coming off the sides. Now, if you go back to the first frame, let's take a look at our pyro burst source, and we'll see what kind of settings we can put onto it. So I'm just going to go through here to where we've got some frames of this. And let's take a look at our settings, and we'll make some adjustments. So inside here, we've got a number of different settings on our pyro burst source, which we can basically adjust. And to start with, let's create our own pyro burst source default version just here so that we can see. So what we'll do is we'll just disconnect this one, and we'll plug in a fresh one here so that we can see that from the starting point. So this is all default settings on our pyro burst simulation here. So what we've got here is you've got an initial you've got a burst type here, which is set to explosion, and then we've got burst animation in here. So it by default will start the start frame at the first frame of your animation, which is 1390 in here. So what I want to do is just change that to 1400, which will give me the ability to have that start at the correct point. And you can see here we've got a little blasty, a bulbous sort of like a blasty effect happening here. So let's take a look at the burst shape setup. So first of all, we've got burst type set to explosion. And if we use this drop down, we can see here we have a muzzle flash as well. And we have a shockwave, which is really cool. So if we go back through the shockwave, you can see here that this could be really helpful for creating dust trails and things like that on the ground from our explosion. And then we have blast rings. And that's a really cool effect for things like science fiction effects and, and magical effects that you might want to put onto VFX shots. So just because these sources are perfectly round, it doesn't mean, of course, that the dust or magic that's being emitted from these, it would have disturbance and gravity and be like dry ice or whatever effect that you wanted to put on it. So you can set up whatever effects you want on these different elements. So just out of interest, let's put on muzzle flash instead of explosion. So we can see here, if we play through the frames, we'll have a start frame of 1400. It's going to go upwards to 401, 402, 403, 404, and then by 1405, it's disappeared. So let's take a look in now our burst animation setting here, and we'll take a look at where we've got our frame duration and our expansion. You can see here we've got a start frame of 1400, so let's just reverse back to 1400. And once again, one of the advantages is we're not using simulation, so we can scrub the frames back and forwards. We've got frame duration 5, so let's maybe set our frame duration to 10. and see how that works. So you can see now we've got a much longer duration as that shape basically expands up quickly to start with and then tapers off. Also, we have the overall expansion. So if we zoom out on this, this element, we can see that its overall expansion is 3. Let's set this to 10 and see what we get. So you can see here now that we've adjusted that, we now have an expansion that goes much larger instead of the original one. And once again, if we set our frame duration to something shorter, like 3, you can see here that you can start very small and then get very big, and then it will fade off. So it's very flexible about the kind of animation and the kind of setup that you want. So let's give this a try, and we'll see, and then we'll go back to burst shape and we'll change some of these other settings in here. So we've got to cache out this simulation. We just go into our file cache here, which is going to cache out our voxelized emission, and we're just going to save this to disk. And what that will do is it will just basically write out your burst volume shape so that you can simulate it. So now that we've cached our explosion, we can play back our simulation and see how that's different. So you can see here we've got a crazy vertical blast effect happening here from the gunshot impact. And as you play it through, you get a totally different looking simulation from the previous one. So if we go back to the first frame here, what we've used is we've used a firearm simulation effect, and then basically when that is voxelized, it creates this violent upwards blast effect here. You can see the voxels of our pyro burst simulation here, which is blasting that temperature and density into the air. And then as that rapidly explodes upwards like a massive bomb, that will basically fill all that detail into the simulation. So let's take a look and we'll see how that plays back in our sim. So if we play that back now, you can see that we have this super cool nuke looking explosion now, because we've got this violent upward movement combined with the buoyancy of the smoke and the explosion. So this is going to look really cool once you place your temperature into it, and you'll get some really, really interesting and nice effects on this simulation. So you can see the detail and the interesting shapes that you get. You get all these tendrils coming out of it, depending on what kind of shape they use for your simulation. Now, if you compare this to the previous shape that we set up, you'd see that the other one has got like a much smokier, rounder shape to it. It doesn't have this giant kind of like mushroom shape to the simulation. So let's take a look at some other options for our pyro burst simulation. So if we just get our pyro burst source here, what we'll do is we'll just save this one, replicate this one over here, and we'll put this one pyro burst source, and then we'll put maybe nuke because it looks like a nuke shape from this one. We'll just cut that off there. And then instead of using muzzle flash, what we'll do is we'll put it back to explosion on here. Now, let's just take a look at our shape here, and we'll see some of the options for creating this blast. Now you can see here we've got all these different tendrily arms coming out of it, and a lot of them are going out horizontally instead of vertically. So let's have a look at the first control, which is the shape offset. So if we scroll through this shape offset, you can see here that we're getting different random shapes as we're basically scrolling through it. So depending on what kind of explosive shape you want, you can go through this shape offset slider and basically get different versions of the different explosion that you want, which is super cool and gives you a lot of different options. Now, inside here, you also have an initial size, which is going to scale this to a good starting point. And this is especially helpful if, for example, you have, a castle wall here, and it's supposed to be a projectile, like hitting the wall, but the initial size is way, way, way too big. Like it could be like something like this, and it's like almost the height of the whole wall. So you're like, no, we need it to just be like small little impact like this. And then that's going to be much easier to set it up rather than having to dial in like tons of different settings. So the initial size is really useful for getting the scaling of your scene correct to start with. Now, another important attribute of this is the direction. So for example, if you have a blast which is going sideways, let's say you've got a muzzle flash coming out of a weapon, you want to be able to set that up so that you can direct it. So you don't want to have it be facing in the wrong direction. You want to be able to control basically which angle that is shooting in. So that's very important to be able to change your direction. The other setting that's really good is this spread angle and roundness. Spread angle basically enables you to, you can direct the explosion more upwards. So if you see this explosion here, let's say we've got a helicopter flying down, chasing our hero, and then we've got bullet hits in the desert on sand or something like that. So that would be like a Mission Impossible type effect where you've got, sand impacts, and you want to blast them kind of like upwards rather than blasting them downwards. So that's the effect where you can basically keep the spread angle facing upwards and get those kind of cool effects. The other thing that's good about this effect is, let's say you have, the spread angle going in every direction, and it's actually a World War II movie where you've got the Battle of Britain. So you've got flak in the air hitting the planes, and you want to basically simulate airborne flak attacks. So you can actually do, set up air bursts using the spread angle of 180, which will basically blast it in every direction, and then you can just use wind and gravity to disperse the explosion. Inside roundness, that's another cool setting. Roundness will basically set how random the shape is. So if you have it the roundness set to 1, you'll have a completely spherical explosion, which could be good for things like fireworks or different effects that you're using. Now, if you want to create a more random, crazy looking effect, which has got a really unusual shape, you can just reduce the roundness and you'll get less, you'll get more randomization on the length of these tendrils and their shape. Now, the number of trailings in here is basically the number of these spikes that it's going to put out of it. And these will be rasterized into the density and temperature that come out of it. In here, we've got trailing separation, and that is showing the density of the points inside the trails. So depending on how densely packed you want this with the density, temperature, and different elements that you want to put into it, that's where you can basically set that up. We're just going to put this back up a little bit more to default settings. And then this is your trailing thickness. So you can put thinner, skinnier trails in here, or you can put thicker ones. So you're basically just adjusting the how pointy these spikes are on your explosion. So that's another cool setting that's very helpful. Now, if you want to do small trails, it's better to set those up using the trails tool, which is a special other tool we'll be going on to in other classes. So I'll just set this back to 90. Now, of course, the most important thing, apart from the shape and the way that it moves, is the components which are in the shape. So inside here, we've got the different sources that it's going to be generating from this explosive shape that it's making. The animation is also important, how fast it's blasting out and what kind of movement it has and how many frames it happens over. And the expansion, but the burst components is critical because it has all of the different elements that you're going to source from this. So, for example, if we say switch off temperature and burn, we'll just have only density. So the only thing that this is sourcing is density out of it. There's no temperature. There's no burn, there's no anything. So basically what you want to do is you want to try and source all the things that you need for your explosion. Now, inside the explosion that we have used, we've basically used a number of different components for the explosion that we used in the training scene. We've used density, which is sourcing out of it. We've used temperature, and you can see here the value scale is set to 5.1 for temperature, and it also has noise on it. We've sampled, we're emitting burn, and we're also emitting divergence. And divergence is called pressure with axiom. So all of these different things are being emitted with our source from our example scene, and they're what creates this super exciting and interesting explosive effect. So if we plug this one in here, and we're just going to disconnect this one, you'll be able to see here that you can see all those different colored elements in our emission there that we've got on our scene. So all of those different sources are basically being emitted into our scene. And then when we play it back on the solver, all of those elements then come to play and basically give you the temperature and the emission. So if we go down here for our pyrobake volume, you'll see here that not only does it have density, but also we have temperature in our scene. So if we just step through the frames here, you'll see here that the temperature is hot at the top where it's got the most temperature from the simulation. And then as it cools down, as it basically goes further, I'll just play this through a little bit more so we can see the animation. You can see here that you've got the hot temperature at the top of the simulation, and then down in the middle you've got it starting to cool off where it's scattering down here, and then it's cool at the bottom and just starting to disperse. So that's basically how the sourcing works. It sources in the density, the temperature, the burn, and the pressure, and then that's the way that it's able to use all of those elements for the simulation. So super cool effect, and really nice to create beautiful, detailed scenes with your simulations. So the pyroburst source is a very versatile and nice system to use for creating your explosions. It's very, very user-friendly and easy to set up and easy to get really cool effects. The main things to remember when you're using it is just keep track of which components that you're emitting into your simulation, and make sure that you've got enough elements in here. You can add them in by creating new elements in here and then using this drop down. So you can put in color, burn, divergence, temperature, and density. And then it's really easy to just rename them so that they're able to be used with Axiom, which is what we're going to look through in the next class. But basically, once you've got those all set up, you've got a really good starting point for setting up an interesting emission type for your pyro simulation. Now, to get good performance, what's a good idea is if you basically rasterize your attributes. So we've got here a volume rasterize attributes, and then that's going to turn your burst simulation into voxels, which you can use as a source in Axiom. And then all you have to do is use your Pyro Axiom solver. And if you keep the settings down low, like 0.1 or 0.2, you'll be able to get almost real-time playback of the simulation in the viewport. And that way you can test out all different settings of your Pyro burst source and get all kinds of interesting and different results for your explosion. Well, that wraps it up for class 2. In the next class, we're going to be taking a look at connecting together our Pyro burst source into our Axiom Pyro solver. So I'll catch you in the next class.